Good morning to all. So today we'll continue with chapter 12, and the last type of question we'll do under this ANOVA technique, that is analysis of variance, is factorial design. When the data is given in the shape of this factorial design, we'll just discuss very simply 2 to the power 3 experiment. This is your question number 5 in the exercise chapter 12. Okay, now what is the meaning of 2 to the power 3 experiment is 2 is the number of levels of each factor and 3 is the number of factors. So basically in this present question we are considering the effect of 3 factors, that is it is 3-way ANOVA. Now I am reading the question. A 2 to the power 3 experiment was carried out to investigate the effect of 3 variables on the extension modulus of knitted fabrics. The 3 factors are: A, whether the fabric was set or unset, they have given the notation minus and plus. B, whether a spreader had been used during knitting, minus for spreader and plus for no spreader. And C is the tightness factor, which is for low tightness factor they have given the notation minus, and for high tightness factor they have given the notation plus. Whatever the question is, basic part is that we are given the effect of 3 factors on the extension modulus of knitted fabrics. Now the 3 factors have 2 levels, that is A factor has A minus A plus level, B factor has B minus B plus level, and C factor has C minus C plus level, and this is the question given. Now how to apply ANOVA technique on factorial design, we will try to understand in this class. Okay, first what you need to do is you have to convert the data in the linear form. I have just written the question which is given in a tabular form in this form, where I have written in the linear form all the factors, that A minus B minus C minus. First I have taken these 4 samples are all A minus and these 4 samples are A plus, then these 2 B minus B plus, and this is C minus C plus, C minus C plus. In this way we have to arrange the data first. Then we'll calculate grand total. Then we'll calculate S1, which is the sum of the squares of all individual readings. SA. Now A means basically A, there are 2 levels of A, that is A minus and A plus. For A minus we'll just add these 4 readings, and for A plus we'll add these 4 readings, and we'll calculate the sum of the squares. Now one reading of A minus has come from the addition of these 4 readings, so we'll divide by 4 and we'll get this value, that is sum of SA. Now for SB also we'll do the similar process, and SC. S grand total is the grand total of all readings, and total 8 readings are there, so we'll find SGT, that is S grand total. Now the second part is, if we have to find the interaction effects, then we have to find SAB, SBC and SAC. I'll show you the calculations of AB, and other 2 you will have to do on your own. Now SAB is basically how many types of AB combinations are there. One is A minus B minus, A minus B plus, A plus B minus, and A plus B plus. So for A minus B minus there are 2 readings, we can see here in the question. These 2 readings are for A minus B minus, these 2 readings for A minus B plus, these 2 readings are for A plus B minus, and these 2 readings are for A plus B plus. Similarly we'll have to do it for BC and AC also, but I have shown you only for AB. Okay, now SAB we get is when we add these 2 readings, now we'll have to divide here by 2 because 1 reading comes from addition of 2 readings. So we'll calculate SAB like this. Now you have to calculate BC and AC, and we'll make the ANOVA table. Okay, now this is the effect of A. This is sum of squares, degree of freedom, mean square, and F ratio. Now for sum of squares of A, we'll have to subtract grand total SGT from SA, similarly SGT from SB, SGT from SC. Now I have shown you the calculation for AB and we got the value, this 2941.67. Since it is AB, we have to subtract the effect of A and effect of B and grand total, and we'll get the interaction effect of AB. For A interaction effect of AC, similarly from SBC, we need to subtract effect of B and effect of C and grand total. So we'll get these two readings, and for this total variation, we'll subtract S grand total from S1 and we'll get these readings. And after subtracting all these readings from the total, we'll get the reading for ABC. Now the degree of freedom, total 8 readings are there, so total degree of freedoms are 7, and 2 levels are there, so degree of freedom for ABC will be 1. So sum of squares divided by degree of freedom will get mean square, which will be the same value because all the degree of freedoms are basically 1 only. So now this ABC readings is 9.25 divided by 1, so error will be 9.25. Now for calculating F ratio, I have to divide all these readings by 9.25, and these are the F ratios. Calculated F ratios I have got is 928.80, 33, sorry, 100.41, 3.63, 1.69, 6.21, 0.33, and 1.58. Now we'll see the table value of F from the for 95% confidence level. For degree of freedom, K1 and K2 is 1 in the given example, and the table value is 161. You can see the table, and now when we compare the table values with the calculated values, we can see here that all the calculated values are lower than 161. So basically no effect is significant in the present case. No effect, neither A nor B nor C nor any interaction effect. But we can conclude that this 100 F ratio we are getting with the main effect of A. So and here, okay, so this is the most significant, major effect. So we need to focus on this factor A, because this is showing some effect, but still it is not, no effect is significant at 95% level, that we can conclude from the given example. It is a very good example, so you can use it in your research projects also. I think you have understood, but still if I need to quote an example, suppose we are studying the yarn strength and we are changing the 3 factors. Suppose you are taking the 2 spindle speeds and taking the 2 twist factors and taking the 2 break draft ratios at the back of the ring frame. So suppose we are seeing the effect of these 3 things on the yarn strength. So you can take 2 levels of all the 3 things and see the effect on yarn strength and take the readings and apply ANOVA technique on 2 to power 3 factorial design, and you can see how statistics help in basic research. So you can also try this and use software. Statistical softwares are also available. So thank you for today. We'll continue in the next class. So this chapter is complete. So we'll continue with correlation and regression in the next class. Thanks for today.